The past is gone. That's obvious. Yesterday happened. It played out. And then it vanished. Your morning coffee, the conversation you had last Tuesday, your 10th birthday party, all of it existed for a brief moment, and then it stopped existing. Right now, the only thing that's real is this instant, this thin, sliding edge of time we call the present. Everything behind it, erased. Everything ahead of it, not yet written. There's just now and now and now. I think most people feel that way, and they feel it deeply in their bones. You look at a photograph of yourself as a child, and there's a kind of ache in it. That kid was real once, and isn't anymore. The room that kid was standing in, the light coming through the window, the particular afternoon, all gone. Replaced by other afternoons, other light, other rooms. The universe seems to be a machine for manufacturing the present and destroying everything else. And I think if you stopped 100 people on the street and asked them, does the past still exist? 99 of them would say, of course not. What kind of question is that? The 100th might be a physicist, and she'd give you a very different answer. Because what most people never hear about, or hear about and then brush aside because it sounds too strange to be true, is this. There is very strong evidence, from tested and verified physics, the same physics that runs your radio and your wristwatch and the satellites in orbit, that the past has not vanished, that it's still there. All of it. I don't mean there in some fuzzy spiritual sense. I mean it the way I'd mean Paris is still there, even though I'm not in Paris right now. The past exists. It occupies a real location in the structure of the universe. And the physics that forces us to this conclusion is not exotic or controversial. It's the most well-confirmed theory of the 20th century. Let me show you how this goes, because it's one of the strangest consequences of a theory you've probably heard of, but maybe never followed all the way to its logical end. Start with something everybody agrees on. You and I are standing in a field. I clap my hands. You hear the clap. We both agree. The clap happened. We agree on when it happened. We agree on where it happened. If somebody across the field also saw me clap, all three of us will file the same report. He clapped his hands at such and such a time. No controversy. That's because we're all standing still relative to each other, and we're close together. Under those conditions, time behaves itself. It does what you expect. The trouble starts when things move. And I don't mean the kind of moving you're used to, cars, trains, airplanes. I mean motion at a substantial fraction of the speed of light. And the reason the trouble starts is because of something Albert Einstein figured out at the beginning of the 20th century, around 1905. Einstein was 26 years old, working as a patent clerk in Bern, Switzerland. Not a professor, not famous, a clerk. And he was turning over a question in his mind that had been nagging him since he was about 16. What would it look like to ride alongside a beam of light? The answer he arrived at destroyed the common-sense picture of time, and nobody has been able to put it back together since. What Einstein realized, and this was confirmed over and over again by precise experiments, is that the speed of light in a vacuum is the same for every observer, regardless of how they're moving. Let me say that again because it sounds so simple that it's easy to miss how bizarre it is. If I'm standing still and I measure the speed of a light beam going past me, I get about 186,000 miles per second. If you're flying toward that same beam at half the speed of light, you'd expect to measure it coming at you even faster, right? Like a ball thrown toward a moving car hits the windshield harder than a stationary wall. But no, you measure the same speed I do, exactly the same. 186,000 miles per second. Not faster. Not slower. Identical. Every experiment ever devised to catch nature cheating on this rule has failed. The speed of light doesn't add to your motion and doesn't subtract from it. It is a kind of cosmic constant that doesn't care who's looking or how fast they're going. And that one fact, that single stubborn fact, unravels everything about time being simple and universal. Because if the speed of light is the same for everyone, then time itself cannot be. Suppose I'm standing on a train platform and you're riding on a train moving past me at tremendous speed close to the speed of light. A flash of light goes off exactly in the middle of the train. The light travels forward toward the front of the train and backward toward the rear. From your perspective, sitting inside the train, everything is symmetrical. You're at rest relative to the train. Both beams travel equal distances, so they arrive at the front and the back at the same time. Two simultaneous events. Simple enough. But I'm watching from the platform. And from where I stand, the back of the train is rushing toward the rearward flash of light, while the front of the train is racing away from the forward flash. The light still moves at the same speed in both directions. That's the rule, the one we just talked about. The speed of light doesn't care who's watching or which way the train is going. So the rearward flash has less distance to cover because the back wall is coming to meet it, and the forward flash has more distance because the front wall is running away. The rearward flash arrives first. So those two events, light hitting the back of the train, light hitting the front of the train, were simultaneous for you, the passenger, but they were not simultaneous for me, the person on the platform. And this is the part where people want to object. They want to say, well, one of you must be right and the other must be wrong. But that's exactly what Einstein's theory forbids. Neither of us is wrong. Neither of us made a measurement error. The universe simply does not have a single universal now. Stay with that for a moment, because people tend to nod and then move on as if they've absorbed it. They haven't. This is genuinely difficult to sit with. Simultaneity is not a fact about the universe. It's a fact about your state of motion. Two events that happen at the same moment for one person genuinely do not happen at the same moment for another person moving at a different velocity. There is no cosmic referee. There is no master clock ticking away behind the scenes that settles the argument. The argument has no settlement. Simultaneous is relative. That's not a slogan. It's a consequence of the geometry of the universe, confirmed by every precision experiment we've ever devised. So what does this have to do with the past? Everything. Because if you and I can't agree on what's happening right now at a distant location, something very unsettling follows. Let me give you a picture that makes this vivid. Imagine two people walking past each other on a sidewalk. One is strolling gently toward the Andromeda galaxy, that is, the direction her body is moving happens to point roughly toward Andromeda. The other fellow is walking the opposite direction, away from it. They pass each other, they're inches apart. By any reasonable standard, they share the same moment in time. They could reach out and shake hands, they're in the same place at the same time. But their planes of simultaneity, what each of them would call right now throughout the universe, are tilted differently because they're moving in different directions. And because Andromeda is so far away, about 2.5 million light years, even the tiny difference in their velocities, a few miles per hour, causes their definitions of now on Andromeda to differ enormously. For one of them, a certain event on Andromeda, say a council deciding whether to send a fleet of starships, hasn't happened yet. For the other, that decision was made days ago, maybe weeks ago. Both descriptions are equally real. Neither person has a better claim to the truth. They're both standing on the same sidewalk in the same city at the same moment by any local measure, yet they disagree completely about what is happening right now on Andromeda. One says the decision is in the future, the other says it's in the past. And that's the crack in the wall. Because if something can be in the past for one person and in the future for another, and both are correct, then you cannot say the past doesn't exist. You can't say the future doesn't exist either. If the event is real for one observer and hasn't happened yet for another, the only consistent conclusion is that the event exists, period. Not just when it's now for someone. Always. This is where it gets serious. Because once you accept the relativity of simultaneity, and you must accept it, the experiments demand it, you are pulled almost against your will toward a picture of the universe that a mathematician named Hermann Minkowski described back in 1908. Minkowski had been one of Einstein's professors at the Polytechnic in Zurich, and when he saw what his former student had done, he took the mathematics and pushed it further. He said something very bold. He said space by itself and time by itself are doomed to fade away into mere shadows. Only a union of the two preserves an independent reality. That's a dramatic thing for a mathematician to say. But he meant it literally. What Minkowski proposed, and what the mathematics supports with extraordinary precision, is that the universe is not a three-dimensional stage on which events happen moment by moment like actors performing on a theater floor. The universe is a four-dimensional block, 3 dimensions of space and 1 of time, all woven together into a single fabric called space-time. And in this block, nothing moves, nothing flows, nothing ticks forward. Everything that has ever happened and everything that ever will happen is already there. Your birth is there. Your death is there. The moment you first rode a bicycle is there. The last breath you'll ever take is there. All of it exists, the way an entire novel exists on a shelf, even when nobody's reading it. The story doesn't appear one page at a time. All the pages are already bound together. This is not speculation. This is what falls out of the mathematics when you take special relativity seriously and don't flinch. The equations don't distinguish between past, present, and future. They have no variable for now. Time is a coordinate, like latitude or longitude. Your position in time is just as real as your position in space, and just as persistent. The year 1912 is a location in space-time, the same way Paris is a location in space. It doesn't stop existing just because you're not there. That doesn't mean you can go visit your past the way you drive to another city. The structure of space-time doesn't allow that, at least not in any way we understand. You're stuck experiencing events along your particular path through the block, what physicists call your world line. And your experience of now sliding forward is just the way conscious beings seem to process their journey through this four-dimensional structure. The block doesn't care about your sense of flow. The block just is. Think of it like a loaf of bread. The whole loaf exists right now all at once. You can slice it at any angle. Slice it horizontally, you get one cross-section. Tilt the knife, you get a different cross-section. Each observer, depending on their velocity, slices the four-dimensional loaf at a slightly different angle. That slice is their now, their personal present moment. But the bread is all there, every crumb of it. You tilting the knife one way doesn't make half the loaf disappear. The person next to you tilts theirs a different way and gets a different now, and they're just as correct as you are. The loaf doesn't care. It just sits there, complete, containing all of time. Some people find this comforting. The idea that nothing is truly lost. That some people find it terrifying because it seems to imply that the future is already written, already fixed, already sitting there in the block waiting for you to arrive at it. That question about free will is a deep one, and I won't pretend to have the answer. What I will say is that the block universe doesn't necessarily mean you have no choices. It means whatever choices you make are part of the structure. They're woven into it. You experience the choosing in real time, even if the result already has its place in the four-dimensional whole. Whether that counts as free will depends on what you mean by the phrase, and people have been arguing about that since long before Einstein. And I want to be careful here, because I know what some of you are thinking. You're thinking, well, that's just one interpretation. Maybe there's another way to read the physics. And you're partly right. In the philosophy of physics, there is a long-running argument between people who hold this view called Eternalism, or the block universe view, and people who hold a view called presentism, which says only the present moment is real. But, and this is a big but, the presentists have a very difficult time making their view consistent with special relativity. They have to add extra machinery, hidden preferred reference frames, things we've never detected to make it work. The block universe, by contrast, falls straight out of the mathematics of relativity with no additional assumptions at all. You just take the theory seriously, follow it where it leads, and you arrive at the block. Einstein himself seemed to accept this. When his lifelong friend Michele Besso died in 1955, Einstein wrote a letter to Besso's family, and in that letter he said something haunting. He said that the distinction between past, present, and future is only a stubbornly persistent illusion. He wasn't being poetic, he was being precise, he was telling them what the physics says, and he himself died just weeks later. So let me pull this together. We started with the most obvious thing in the world. The past is gone, only now is real. Then we found that the speed of light being constant for all observers forces us to accept that simultaneity is relative. Two people in the same room can disagree about what's happening at this very moment in a distant galaxy and both be correct. That means now is not a universal fact about the universe. It's personal. It depends on how you're moving. Right, Privot? And once you realize that, you can't maintain the idea that only the present exists, because one person's present is another person's past and another person's future. The only coherent picture is one in which all of time, all of it exists at once. A frozen, four-dimensional block of everything that was, is, and will be. Your childhood is still there. The Roman Empire is still there. The death of the last star, trillions of years from what we call now, is there too. We can't reach any of it. We can't change any of it. But it hasn't vanished. The physics won't let it vanish. I know there are people who push back on this. They say that's just the math. The math doesn't tell you what's real. And look, I respect that argument. I'm a physicist, not a philosopher. I deal with what the equations say and what the experiments show. But I'll tell you this, every time in the history of physics that someone said the math works but it doesn't mean anything real, they turned out to be wrong. The math was trying to tell them something. Atoms were real. Electromagnetic waves were real. Curved space-time was real. The math was not lying. So when the math tells you that the past still exists, maybe, just maybe, you should listen. I want to leave you with one thought. When you remember something, a face, a voice, a day that mattered, you tend to think of it as a ghost, a fading copy of something that was once real, but isn't anymore. You think the memory is all that's left. But if the block universe is right, the memory is not a copy. The memory is a signpost. It's pointing at something that is still there, still just as real as the moment you lived it, just located somewhere else in the structure of things. Whether that makes you feel better or worse, I think, says more about you than it does about physics. But either way, it's true, or at least it's as true as anything we know. Think about that. What moment from your past would change the most for you if you really believed it still exists somewhere? I'd like to hear your answer to that.